Okay, so today I want to show you how to name ionic compounds. There's a couple different kinds that I have to go through, so I'm going to show you each one step at a time. Alright, so the first kind of ionic compound that you can have is made of just monatomic ions. So when I look at a name like Al2O3 or a formula, and I want to write the name, I want to identify what the cation and anion is. Now, 95% of the time, that first element is your cation. So I draw a line after my first element. Now, I will caution you, watch out for NH4, because ammonium is a positive polyatomic cation. So just watch out for that one. Whenever you see that at the beginning of a formula, that is the cation. So, looking at my examples here, the first part is the cation, and to name that, I just call it aluminum. So the cation, the name of the cation does not change from the name of the element. So I just write aluminum. It doesn't matter that there's two of them. All I do is name that first cation, Al, and it's aluminum. Now the second part of the name deals with that oxygen. It doesn't matter that I have three of them. There's only one type of element there, so that is also monatomic. So when you have a monatomic anion, you change the ending so that it ends in "ide." So that's oxygen, but I want to change it so it ends in "ide." So the first example is aluminum oxide. So right now, pause the video, try the next two, and then we'll come back and give you the answers. All right, so I do the same thing, line there, so Ca is calcium, and the second part is chloride. And for the last one, draw a line there, sodium, and the second part is bromide. So that's just dealing with monatomics. So now we're going to come at it from the opposite direction, and we are going to formula write with monatomic ions. So this time I'm given the name, and I want to write the formula. So, little bit of opposite here. So for the first one, sodium is Na, and I use my periodic table to determine the charge, which is +1. And now you really want to hone in on the ending when you're formula writing for that second ion. Since it ends in IDE, that's telling me that that element is monatomic. So that is just a fluorine. And again, I use my periodic table to determine the charge, and fluorine's a minus. So now I'm saying plus and minus, but it's technically 1 plus and 1 minus. And I'm going to show you a trick to write the formula. All we're going to do is cross the charges and write those numbers as subscripts, but on the other atom. So I get Na1, F1, and I don't have to write the ones. So that is the formula for sodium fluoride. Now try the next two, and pause the video, and when you get back, I'll show you how to do them. All right, so the first one is calcium, which is Ca, and that has a 2+ charge. Oxide is just an O with a 2- charge. So I cross, and I get Ca2O2. Now this one had a little bit of a twist, and some of you might have taken care of the problem here, but those 2's can be reduced. So the formula for this one would be CaO. For the last one, I put potassium, which is a plus, nitride, which is N3-, I cross, I get K3N. And that's how you formula write with monatomic ions. Okay, so this time we're dealing with polyatomic ions, which is a little bit different than what we were doing before, but it's really not that different. So you'll want to have your ion sheet that you got in class, and you'll want to use that to help you write these formulas. So I cut it after the first element. So the first element is Na, so that is sodium. That's still monatomic, so that hasn't changed. But the second part of the name has more than one element this time. So what I would want to do is go on to my formula sheet and find CO3. Once you find CO3, whatever its name is what you should write down. So CO3 is carbonate. So the name for that is sodium carbonate. Now pause the video, try the next one, and then when you get back, I'll show you how to do it. Okay, so same deal. First part is potassium, and then the OH, which is on my ion sheet, is hydroxide. All right, so for the next part, I was given the name and I want to write the formula. So we're going to do the same thing we were doing before with crossing the charges. So magnesium is Mg2+, and sulfate, see how the endings changed? So since it's not an ide, it's not just the sulfur. So since it ends in ATE, I need to go to my ion sheet and look up what sulfate is. So sulfate is SO4 2-. So now I can cross the charges, and I get Mg2 SO4. Now when you have more than one polyatomic, you use parentheses, SO4 2. But those numbers outside of the parentheses can be reduced. So the formula should be MgSO4. Sulfate is SO4, so I cannot reduce that 4. I cannot do anything with that 4. I can't distribute. I can't do anything with it. So if I see sulfate in my final formula, I should still see sulfate. So try the next one, and when you get back, I'll show you how to do it. Okay, calcium is Ca2+, and nitrite is NO2-. So I cross my charges, I get Ca1, parenthesis, NO2, 2. And I want to leave it just like that. I can't reduce those 2's, I can't distribute, I can't do anything like that without changing nitrite, so I don't want to do anything else, I just want to leave it as CaNO2, 2. All right, so the last part of ionic naming is some of these elements, or cations I should say, have more than one possible charge. They're called multivalent cations. So if they're multivalent, we need to use a Roman numeral or Latin to differentiate between the two different kinds of ions. Now, before I get started, I'll let you know that the Roman numeral way is way more common today, but I will still show you guys how to do the Latin because that will still pop up every now and again, and you'll want to know how to do that. So, the Roman numeral stands for the charge. So if you see iron 2 is 2+, iron 3 is 3+. Now, the Latin root for iron is ferrum. Spelled that wrong. So the Latin root is ferrum. So depending on if it's +2 or +3, I want to change the ending to represent that 2 or 3. Now you notice with my first example, the ending is OUS. That ending corresponds with the lower charge. If it's the higher charged one, the ending would be ic. Again, with our Latin roots, I just want you to know 4. I'm not going to go into the entire periodic table showing you the Latin, but those are the 4 Latin roots that you'll want to know for this naming, if you're going to do the Latin portion of this. Now, the next question that you should have is what elements on the periodic table need Roman numerals? And I'm going to highlight some, and there's more, but these ones are really, really common. So chromium through copper, mercury, and tin and lead. So whenever you see one of those cations, you need to include a Roman numeral to signify what kind of charge that ion has. All right, so let's do some examples. So the first one, I'm still going to cut it just like I was doing before. So my cation is copper. And now I want to ask myself, is that one that needs a Roman numeral? And if you look at the periodic table that I just showed you, it is. So I want to just put some parentheses there, just to save place. so that I know I need to put a Roman numeral there later. For the second part of the name, I have Cl2, still chloride. It's just the chlorine by itself, so I make sure it ends in IDE. Now here's how you find what the charge of that copper is, because that's what needs to go where my Roman numeral is. So, I know that chlorine's charge is -1, and there's 2 of them, so this side's -2. So that means the copper on the other side has to be +2 to cancel off those 2 -1 chlorines. So the charge of the copper is +2, so that's the Roman numeral that goes in the parentheses. Try the next one, and when you get back, I'll show you how to do it. All right, so for the next one, I cut it right there. SN is 10. 10 is one of those ones that need a Roman numeral. And now the second part of the name was CO3, so I looked that up on my ion sheet, and that's carbonate. Now I have to find the charge of 10. So carbonate has a charge of 2-, so that means 10 has to be +2 to cancel that off, so my Roman numeral would be 2. Now, the last component of the naming portion that we were doing here at the top is the Latin. So, I'm going to show you how to name this using the Latin. So, copper 2 chloride. Copper could be copper 1 or copper 2. And I've got that information from my ion sheet. So now, when we were talking about this a couple slides ago, the lower charge would have an OUS ending, and the higher charge would have an IC ending, or an IC ending. So the Latin root for copper is cuprum, and this is copper 2, so that's the higher charge. So this one would be cupric chloride. So I want you guys to try this one. Try to name that using the Latin roots, and when you get back, I'll show you how to do it. All right, so 10 could be a +2, or 10 could be a 4+. So this is 10-2, so this is the lower charge, and I know that the Latin root for 10 is stannum, so this would be stannous carbonate. Just another way to name it. So you're probably asking yourself, on a test, would I have to write the Roman numerals or would I have to write the Latin? Well, I'll let you guys know that you could do either, and I'm still going to mark it correct. Now, the Roman numerals are way more common today. So this is way more common than cupric chloride. So I would prefer this way, but if you write this, that's fine. Now, when will the Latin come into play? I might give you this and ask you to write the formula. So if I do that, you'll need to know what this cupric means. Is that copper 1 or is that copper 2? So just keep it in mind. You will have to know a little bit of the Latin. Not a ton, but a little bit. Now, the formula writing has not changed at all. So lead is Pb, and that Roman numeral there is telling me the charge. So that's kind of helping me out. I don't have to go to the ion sheet. Nitrate is NO3-, so I cross my charges and I get Pb, NO3, 2. So that's how I would write the formula. That's still the same that we were doing before. So no change in that. All right, so that's how you name ionic compounds. We'll be doing covalent in another episode.